Hello everyone, good morning, good evening, welcome back. Welcome to Cloud and DevOps Back 58. So before I start the session, I just want to give you a quick recap on what's being covered in the previous session. Previous session, we were discussing about network. How do you access the number of pods that are available in the cluster? Okay, so front end can have 3 pods, back end can have 10 pods, and some other component can have X number of pods. How front end can talk to back end if the number of pods are more that has each and every IP address, right? So that's when we talked about services. Okay, a service in Kubernetes. So we discussed about a cluster IP service. By default, if you don't mention the name of the service is going to be attached to all the pods. So whatever the request that we want to talk to this particular pod will hit this service, and the service will send the request to the backend pods. And the type of service that we typically use is cluster IP. Cluster IP is absolutely internal to the cluster. What if I want to expose something to the external network? That time you will be using a service called as a load balancer. So load balancer is a type of service that really
Not able to hear you, Manoj. Hello. Hello.
Yes, Maz, we are
Uh,
not able to hear you.
how about now?
Yes, yes.
yeah, it
No,
is
no.
better.
Okay, all right. So we discussed about the cluster IP service. So cluster IP is also a kind of load balancer, but is internal to the cluster. So it is only for the purpose of balancing the load between the pods, okay, which can be accessible only within the network. And if you want to use the cluster IP service, you don't have to mention the type of service. Okay, that's it. It's very simple. So the next thing is, okay, load balancer service. So the load balancer service is like whenever you want to expose something to the external network, that time this should be coming into the picture. All you need to do is you just need to mention it. We also discussed about what is the difference between this port versus this port. This is like whatever the request that the service has to listen, whatever the request that it has to listen to the container, the pod. Okay, the next type of service is node port. This really opens a port on the top of your node so that you can directly hit the service using the node's IP address followed by the port that you have mentioned. Okay, the next is external IP. This is the funniest thing. This is the most nice thing. It's just like creating a CNAME record. We also discussed what if the service that you want to access and the service that you're trying to access and the service from where you're trying to access are in two different namespaces. Okay, so I'm trying to access this. For example, if you look into this, okay, I want to connect. I connected to expense namespace pod. From there, I'm trying to hit the curl exec pod. Okay, so if you try to make an exec pod, okay, the DNS record for it is this, which means nginx service.default.service.cluster.local. This is the fully qualified domain name. So whenever you want to call a service which is in other namespace from where you are calling from, then in that case you need to use the cluster IP, fully qualified domain name. Any questions on this topic? Any questions, anyone? Okay. So there is also a service called as a headless service. Okay, headless service in Kubernetes. Okay, this is majorly used for. Okay, so for example, so to understand the headless service, let's try to take an example. Okay, this is somewhat interesting. Whether we use it or not is secondary, but let's try to gain much knowledge out of it. Okay. So typically, let's try to assume you have, okay, you're having 3 records of a database called as MongoDB database. Okay, let's assume this is a MongoDB database. Okay, so here we have 3 pods. MongoDB 01, 0, pod number 1. When I say this, it is a stateful set.
Manoj, if you are speaking, I'm not able to hear.
No, Manoj, we are not able to hear
No,
you.
Manoj.
I don't know what happened.
Now I can hear.
Now it's clear.
I don't know. Let's see how it works. Okay. Okay. So typically, if you're talking about the databases, how it works is, okay, data is very much important, right? And based on whether the operation that we are trying to make is just a read operation or write operation, it works this way. Okay. So whatever the data that you stored in the primary copy will be replicated to the other 2 copies. Okay. Keep this point in mind. Okay. Whatever the data that you write in this will be replicated to this and this copy. The reason why they do this, because in case if you lose this particular disk, you still have the data, the same data. Okay, so when you say primary copy, on this copy, okay, users can make a read operation and write operation as well. If the copy is read-only copy, okay, if the copy is read-only, then only read operation. Okay. For example, if someone came just to make a transaction, so in that case, the request will go to the primary pod. Okay, if someone just want to read the data, their connection should going to be here or here. This way, we can make sure write operations will happen here, and whatever the data that is being written here will be replicated here. Okay, so that write operations will happen in this present replica and read operations can happen in this particular case. If this has to happen, okay, the person who is initiating or the service that is initiating the request should have, okay, should know whom to talk. Okay, that's when okay, that's when the headless service comes up into picture. Headless service is a non-network service. Okay, so non-network service where you can hit the pod of your choice. Okay, it is not going to have any sort of IP address. Okay, using the headless service, you can mention, okay, I want to talk to read replica. Okay, I want to talk to write replica, or okay, I want to talk to read replica. You can explicitly mention it. Okay, clear? Clear, guys? Are we clear? This is how it works. Okay, so nothing much to talk about it. So let me try to show you what it means. Okay, so can anyone hear me again one more time?
Yes, Manoj.
Yes,
All
Manoj.
right. Okay.
Yes, ma'am.
So this headless service is a concept that comes only in the what do you call Kubernetes stateful set. Okay. So what this means is sometimes you don't need to load balance. And I told you, you really don't have to balance between these machines. Whatever the request that comes up, randomly it has to go here or here or here. No, that's not the case. If the request that wants to make a write operation, it has to go to this replica. If the request that just want to make a read operation, they have to go to the read replicas. If that is the case, if you use a conventional service, it just randomly goes to one among them. I don't want that. Okay, so you can use a headless service to interfere with other service discovery mechanisms without being tied to the Kubernetes implementation. Okay, so if you want to deal with a headless service, a cluster IP is not allocated. A kube proxy does not handle these services. Okay, as I mentioned, there is no load balancing concept. So a headless service allows a client to connect to whichever the pod it prefers directly. Okay, services that are headless don't configure routes and packet forwarding or virtual IP addresses. Instead, headless service reports the endpoint address to the individual pods via DNS records through the cluster's DNS service. Okay, so yeah, this is another thing. How do we create a headless service? This is how you can create a headless service. So you are creating a service, name of the service, and you are attaching it to the pod. Okay, a specific pod. So and then you are telling this pod go to this particular pod and this is the IP address. That's what you're doing. Simple. Okay. So yeah, clear on this. So this only comes up when you're dealing with stateful set and that two databases. All right. Next. Next is a very important concept. How do we control what can be the maximum resources you can pod? Okay, so go here. For example, this is a pod that is running. Okay, so and this is a service that has 8 GB RAM and 16 processor. Okay. If this is the case, if I ask you, okay, what can be the maximum CPU that the MongoDB pod 0 can use? What is the maximum CPU that this guy can use? How do you define it? And if the pod is having two control, for example, let's go here, one more, and this pod is having two containers. Who defines what is the maximum CPU, what is the maximum resources that you can utilize this containers? So if it is a if it is a physical box, you know, the box that can use a maximum is 8 GB CPU and 16 CPUs, and it can't go beyond it, right? Yeah. But if it is pods, if you don't define limits, if you don't define what is the maximum it can use, what is the maximum it cannot use, then whatever the resources that are available to this particular node, it can run to the maximum of it, and sometimes it even causes the downtime of the node. So how can I define, okay, and how to define what are the minimum CPU and memory needed for the containers in the pods to start? Okay, that means if if the minimum needed resources mentioned in the pod are not available on the node, then that pod won't be scheduled. Instead, it will be in the pending state. Okay, so this is what it is. Next, how to define what are the maximum CPU and memory for the containers? Okay, if you define the limits for the resources, whenever container reaches the limits in the pod goes for a restart. So how to deal that? How to deal that? That's where resource management comes up into picture. Okay. Limits, requests, and limits. Okay, so let's go ahead and talk about it. Resources in Kubernetes. Okay, resource management for pods and containers. So using the concepts of limits and requests, we can define what is the minimum CPU and memory that are needed. So, and what are the maximum CPU and memory are needed. And you see another entity, this is something just recently in last 1 to 2 years they introduced. This is like, what is the page size? Okay, whenever you're dealing with the databases, okay, the page size comes up into picture. Page size is like, what is the maximum data that a process can utilize? Okay, but let's not get into that. So what is the page in memory? So a page in computer memory is a fixed block of data that is used for the memory management. Okay, so this majorly comes up when you're dealing with the database based applications, the stateful based application. There you can define what can be the maximum page size, what can be the minimum page size for the data transfer. Okay, for the memory transfer. So it's not about storage, it's about memory. Okay, so CPU and memory, you know this. So request.memory means what is the minimum CPU that is needed for the pod to start. That means that much CPU and that much memory has to be allocated. So what is the maximum CPU that it can use, and what is the maximum memory that the container in the pod can use? Okay, that's what a limit means. Okay, so this is how you can define limits and requests. Okay, so let me try to show you that. For example, I think it's completed. Okay, and alias cap. Okay. Okay, done. Okay, done. Let's try to publish. Let's try to clone it. Uh, okay. Now I would like to resources. Go here. Again, keep in mind, limits and requests are not per pod. Limits and requests are per container within the pod. Okay, keep this point in mind. Limits and the requests are at container level of the pod. If we have two container, if we have again, there are both pros and cons for defining limits and requests. If you define the hard limit, in case if a process is going longer, and if there are no, and if the request says that you cannot go beyond this, if the limit says you cannot go beyond it, goes for a restart, failure in the process. And if you don't define it, the process will run, and it also reaches a situation where the node runs out of resources and the pod dies, and the node dies. That causes the downtime of the node. Okay, so it's all about tuning. You need to tune the system. You should know what process is going to run, what process is going to take, and then based on that, it works. Okay, clear? All right. Okay, so this is one point I want to say. This means front end hyphen pod is going to run some image. So what image? For example, just say docker.io nginx. Okay. Okay. So this means for the pod to start, a minimum 64 MB and minimum 0.25 CPU needs to be allocated, and it can go to a maximum of 128 MB of memory and 500 MB of resources. Okay. How pods resource requests are scheduled. And again, one more thing. So you might think, okay, Manoj, as per the resource requests and limits, my pod is scheduled on the top of this particular node. As out of these nodes, okay, when the pod was scheduled by the scheduler, the pod was scheduled on this type of node because it has the needed limit requests of CPU and memory. But when the pod was scheduled, it was under impression that it can allocate the resources. But when after 1 or 2 days, when it demands till the memory limits and CPU, if the node is not having the resources, then what will happen? Obviously, it goes for a restart and it's going to be started in the node that has those many resources. Okay, only the requests are guaranteed. Limits are not guaranteed all the time. Okay, IMP. Only limits are guaranteed. Requests, it's other way around. Okay, only requests are guaranteed. Limits are guaranteed. Okay. All right. What will happen if there are no resources that are mentioned as per the request? The pod will stay in the request state forever. Okay. So let me try to publish the code. BGP CAF 016. Can you see this? Okay, now it came for the running state. Now I'll deploy one more pod. What I'm gonna do is this time I'll say a lot of resources, extra pod. I'll say 6 GI is needed, and 4 cores is needed, and for this 8 GI. Obviously, I don't have those many resources. See what will happen. Okay, extra pod. This is just for the purpose of demonstration. Okay, keep control get pods, right? Now see extra pod is created. Now can you see this? It is in the pending state. Okay, if you get this into pending state, if you want to know the reason, definitely the reason could be didn't satisfy any of the condition or there are no resources available. And Casey describe the pod. You can see it says 0 of 1 nodes are available, insufficient CPU, insufficient memory, preemption. Okay, so there are no nodes available to meet whatever is needed. So it will stay there forever. And another important thing when you're troubleshooting Kubernetes is in Kubernetes there is an option called as kube control get events. So this is going to show you all the events that are happening, good events and bad events, and you can also see scheduled. Okay. In case if you want to start any sort of troubleshooting, the very first thing that you can do is kube control get pods. That option can bring up a lot of values. Any questions? Any questions, anyone? Any questions? Am I audible, anyone? Check.
Yes, Manoj.
Are we clear so far?
Yes.
Okay, all right.
One question, Manoj. You said this is for containers only, right? And what about pods? Is there any kind of functionality?
Again, you need to watch session 1, Sumit. You need to watch.
Okay.
So pod is just a wrapper. It's not really a compute resource, right? Pod is just a wrapper.
Mm-hmm.
Pod is just a wrapper. What is a wrapper? A wrapper is a script that is going to invoke other script. So the issue comes up only in the container, not in the pod. So you name one fault with respect to the pod. We are talking about actual tasks. So you are assigning, see, these are the actual computers. So container are the actual computers. The actual fundamental task is happening through CPU and memory, right? This pod is just a wrapper. It's just hold this. That's it. Okay. Clear?
Okay.
You said that what if there is some issue with the pod, right? Clear? Is this what your question?
Yes, yes, Manoj.
But pod is not for issues to come up. You never get through pod. You refer. Okay, I got an issue in my pod. That means you're referring to the issue that you got in the container. Okay. Clear?
Correct. Okay.
I mean that's okay. We can spend some time. Are you clear?
Yeah, for now I'm clear.
No, no, you don't have to compromise. Speak. That's okay.
No, that's fine.
No, not that's fine. That's fine. Just go ahead, ask. That can be helpful for others. Go ahead.
Actually, I have to check again some videos, then I will do ask the questions. I think I'm still
Catching
confused
up.
in pots and containers.
No, you.
It looks like.
Uh, okay. It's a very simple thing. You are complicating it. Just watch it. After 1 or 2 days, you feel, hey, Manoj, this is quite easy. You'll say that to me. Okay.
Mhm.
I'm quite sure.
Correct.
Again, tomorrow is holiday. Day after tomorrow is holiday. So your task is you need to catch up with the last 4 sessions.
Yeah, definitely, definitely. There is the plan.
Yeah. Call me over the weekend as well if you want. Okay. I don't mind.
Sure,
Okay.
I will.
So kube control events is another command that shows you the events, the good events or bad events that are happening in this. So what's happening? Okay. What is there any node pressure or any sort of issues? Everything you can find it here. All right. Perfect. Okay. All right. The next thing is, okay, limits and requests. Okay, what happens? Okay, if there are no requests, then if there are no requests that meets the node? Okay, then if node is not able to allocate the needed resources, then the pod will not be scheduled. What if I want to reach to the max of my limits that are mentioned, and if the node is not able to allocate, then what will happen? In that event, what happens is the pod is going to be restarted in a node that has the resources. Okay, always keep in mind requests are honored. That means requests are guaranteed, not limits. Next thing, how to see how to check the resource saturation of pods. Okay, how to see the resource utilization of nodes. Okay, so for this you need to install a component metric server. Okay, if you are using Kubernetes cluster, Google Kubernetes engine, you'll get that by default. But if it is AWS or Azure, you need to install this metric server. Okay, then it collects the metrics and shows you. Okay. So for example, if you're talking about this, kube control top nodes. Okay, it should show you error metrics API not available. Kube control top pods. It shows the same thing, metrics API not available. Okay, for that to work, you need to install monitoring. Okay, so come here and let's try to install it. How it works. Okay. Go with the GitHub page. So Kubernetes 6 is the company name or the community name that offers metric server. Let's understand. Metric server is a scalable, efficient source of container resource metrics for Kubernetes built-in auto-scaling pipelines. So you need to install it. How do you install it? Metric server can be installed either directly through the YAML manifest or via from the Helm. Okay, so first let's try to delete this, apply, right? I just deleted the part. Okay. Service 8013. Yeah, next, let's also deploy one more thing. Okay, done. The pods are running. Now, what I want to do is I just want to install this. So you can install this using this. Now, what it's going to do is it has a very big manifest file. If you try to see this, okay, they are supplying this way. What happened? Why didn't show up? Maybe downloaded and installed. Oh, okay, so downloading a file. Okay, never mind. Okay, now what I want to do is I just installed it, right? Let's see what will happen. KC. Okay, now what it says is there is something called as RBAC, role-based access control. Who can do what can be defined by this. It is created a cluster role building, okay, service metrics and deployment metric service and API service registration, something got created. Okay, so you get deploy, you can see, okay, and where it is created, deployment metric server. Where did it come to? Let's try. Okay, see. Get deploy -a, maybe in the cube API system. Yeah. So can you see this in the cube system? Metric server has to be deployed in the cube system. So by default, it deployed there. Okay, done. Now let's try to see KC get parts. Now you can see this still didn't come up. KC get parts. Why this is not coming up? KC logs -f. And again, this is a single container pod. If it is a single container pod, you don't have to mention the container name. Okay, if you have more than one container, how do I know whether it has more than one container or not? Because it is /1. Then I can say -c cont name. So that means which container looks in the pod that you want to stream. Okay. So you need to mention cube system. It says the not pod valid metric server. Because it's not really up. You cannot use -f when the pod is not up. Error, container metric server is not valid for pod metric server. What is the reason? Oh, come on. So it created readiness probe failed. Okay, so these are health checks. Readiness probe failed. HTTP probe failed with the status code 500. So kubelet preferred types is equal to internal IP, external IP, and host name. Look at the events. Uh, okay, perfect. You got a log. Okay. That means this metric service is trying to connect to this metric service, okay? Cube API server using HTTPS. TLS failed. There we are not using any certificates here, right? And that's the reason it is failing. I get it. Now what I can do? Uh, so I just want to make sure TLS should be. So this is the hint, okay? So TLS shouldn't be there. So what I can do? Are there any other options? Okay. Yeah. Okay. So depending on your cluster setup, okay, you may need to change the flags. So in my case, I do not verify the CA of serving certificate presented by the kubelet. Okay. Okay. All right. So I'll go with this option. So where can I find this option? So KC get deploy -n. So metric server, right? Kube control edit deploy metric server. If it is a Helm chart, you do a different way. We'll see that later. But let's try to bypass this. I just want to add this option. Where are the containers? Uh, mm, yes. So here we can say this. So there is no such option. So let's try to add it. Kubelet insecure TLS. And then preferred kubelet IP address. Let's just go with internal only, because if external comes up, definitely you need to use IP address. So just limit this so that it is confined only to that. Okay. Get ports. Okay. Can you see this? KC get ports. Ha, ha, ha. Mm. I'm just trying one more time because it's pretty straightforward. If it is actual E case, you don't see this, by the way, okay? Oh yeah, it's up. Perfect. It's up. So one of the parties up. Now KC top nodes. Guys, can you see this? Earlier, when you deal this for the first time, when you try to run the kube control top parts, you never got it. Now you can also see, KC. Can you see this? So it tells you what is the utilization of CPU, what is the utilization of memory, and what is the utilization of your CPU, and what is the utilization of your memory on this particular node. At this point of time, the number of CPU cores which are utilized 283, and in percentage this, and in memory, this is what is that available, and 54 MB is something that is used. Okay. If you want to install the metric server, this is how you can do it. So this shows what is the utilization of it. All right. Any other questions? Any questions, anyone? Questions? I want to take a pause. Questions? Okay, all right. Okay, so this is how we can make use of it. So the next thing is quotas. Quotas is a very nice concept in Kubernetes. Quotas. This is like defining limits. Okay, defining limits. I think that my namespace can have a maximum of 100 ports. The namespace X can have a maximum of 16 GB memory utilization only. See, typically, if a Kubernetes cluster that you provision is a shared Kubernetes cluster, that means if multiple teams are using, and you want to make sure each and every team, whichever is high priority, which is low priority, you assign them a maximum resources that you can use. Okay, namespace X can have a maximum of 16 GB memory utilization. Okay, or you can say a maximum of 100 secrets can be created in a namespace. So you can define these quotas. Okay. All right. Assigning quotas to namespace. Okay. This comes up into picture if we are using multiple namespaces in the cluster. Okay. Quotas majorly comes up in an efficient and a shared namespace environment. Okay, quotas majorly comes up in an efficient and shared environment. So let's talk about it. Okay. Uh, Quotas. Resource quotas is the right word. So when several users and teams share a cluster with fixed number of nodes, there is a concern that one team will use more, another team will not be using it. Resource quotas are a tool for administrators to address this concern. Okay. All right. So next thing is resource quotas works. Different teams works in different namespaces. We already discussed. The administrator resource one resource quota for each namespace. And if creating or updating the resource, for example, I was being allocated with 100 GB memory per namespace. And if my Kubernetes cluster within the namespace that I was being tagged with 100 GB as the maximum memory that I can use, if I go beyond 101, 100, what will happen is it's going to show a 403 error. Okay. If creating or updating a resource violates a quota constraint, the request will fail with HTTP status code 403 for done, saying that if the constraint that have been violated. All right. If quota is enabled in a namespace for compute resources like CPU and memory, users must specify requests or limits for those. Yeah, we can. Enabling resource quota. So for example, if you want to use resource quota, you need to resource quota support is enabled. Again, in Minikube, it's not supported. You need to go through the Kubernetes cluster. So you need to enable the API server. There is an admission controller. Admission control is like a feature. Okay. In Logstash, we are using plugins to enable the feature, right? Similarly, you need to enable admission controller plugin with the resource quota flag. Then it will work. Okay. So compute resource, okay, limits.cpu, limits.memory, okay. So like that you can mention. So what are the type of resources that are quotas available? Object count, okay. So the quota that you can create, how many number of maximum services that can be created, what can be the maximum config max that can be created, what can be the maximum jobs that you can create, you can define it. Okay. And the quota scope, okay. So each quota can have an assignment of set of scopes. A quota will only measure the usage for the resource, and if it matches the intersection, it will. If not, it just gives you 403. Okay, so this is an example of it. Resource quota. So yeah, just go through this. I don't want to spend more time on it. It's more or less like an admin stuff. Okay, so anything else? Uh, Kubernetes, AWS, um, Yeah, this is an example of it. Okay, so quota example, and in this for you are creating this for this particular namespace, you can have a maximum of one pod, and it can go, and this pod that you can create is a maximum of one, and if you attempt to create more than one, it troubles you, and the maximum CPU and it can use is this much. Okay, so this will be granted. So what do you mean by minimum and maximum? Minimum requires CPU and memory. That means when the namespace is provisioned, that will be granted exclusively with 2 GB memory and 5 GB memory and 2 CPUs, whether you use it or not. Okay, but you can use a maximum of this. Okay, this is one thing. Okay, so let's try to create it. Okay, so what I can do is let's try to create a namespace. Okay, see, create NS expense. Okay, so you can see the expense namespace, namespace, MCB demo, photo demo, count. Okay, what I'm gonna do is, I'll just say 2 parts. Okay, and it can go, you can create a maximum of 2 parts, and those 2 parts can use a maximum of 4 CPU and 10 gig of memory. Okay, so yeah. So I'll just say CPU. So 500, that means half CPU, 600, and then memory, I'll just say, okay, all right. Let's see first, I don't know whether in Minikube it supports quotas or not, but it should, but let's try to publish it. Yeah, okay, I know that. Expense. Casey, get. Okay, you can see kube control get quotas in this. It says pods. You can go to a maximum of 2, and right now there are no pods, and requests 0 of 500. That means how much out of half CPU that is allocated, how much is being used? Out of half GB memory, 5 GB allocated, how much is being used? What is the maximum CPU that is being allocated? Okay, that's what it meant. Now, what I would like to do is I just like to deploy a pod. Let's keep it very simple, very, very simple. Okay, debug pod. Debug 001. Okay. Okay, what is the error that you got? Quota demo CPM assessment is limits and requests. Okay. So for this to use, you should mention limits. Okay. Failed quota. Why? Okay, it says error from the server, error when creating quota.ml pods debug 001 and 00 failed quota, demo quota must specify. Yeah, if you are using this, you need to make sure you mention the limits and requests. If not, how does it come to know whether this pod, how much resources that it want? Okay, so if you are defining the limits, quotas, you also need to use the limits and requests. That's what they meant. We'll go very basic, okay? Okay, done. We'll also go the same path. Publish it. P. Okay, perfect. Can you see this? So another important point, when quotas are defined, pods or deployments should have limits and requests defined. If not, it will not work. When quotas are defined in a namespace, pods or deployment should have limits and requests defined. If not, resources won't be deployed. All right, clear? Now, get pods, not expense, right? Now, now I'll create one more pod. Now, if you come here and try to see get quota, you can see minimum 2 to 2. A maximum that you can go is 2 pods, and out of which 2 are already scheduled. Okay, and out of CPU 500, you are just using 1th of it, and it's very less CPU and memory you have utilized. But the cap for the number of pods is 2 by 2. That means you already reach. Now, if you try to attempt one more, let's see what will happen. Now, what will happen? Can anyone tell me? What is the error that you are getting? Error from the server, forbidden. Error when creating this. Okay, pods D003 is forbidden because exceeded quota. Okay, I told you, right? You get a 403 error. KC get events, FNN, expense. Okay, you can see what happened in this. You can see that it's not really got scheduled. Yeah, can you see this? You really got the forbidden error, 403 forbidden. Okay, so yeah, this will not be scheduled. So this is the error that you would get. Sample error. Okay, this is what I was talking about. Any questions, anyone? So next is security. Okay. Also, we also have something called as a probes. Okay, let's talk about this as well. Health checks. Probes. Okay. Health checks in Kubernetes. Okay. So guys, how do you know whether an application is up or not? Anyone? Anyone? How do I know if an application is healthy or not? If I ask you, are you healthy or not? What will be your answer? Okay, I'm healthy because I'm doing good. I'm going to office. I'm doing my job. I'm healthy. That means if you are whatever you are intended to do, if you're doing without any issues, that means you're healthy. If you're not healthy, your day-to-day operations won't be happening, right? Likewise, for example, you say Google browser, Google search, health check, endpoint. Okay, it says /health, right? Now I'll do curl google.com. Okay, you're getting this response, right? Help. Google has moved this here, www.google.com/health. So curl example. Okay, typically for each and every applications, okay, there will be one health endpoint. Okay, so if you want to see whether your application is working or not, okay, localhost health. Okay, this health is the endpoint that will be defined by your application development team. So you need to ask, okay, whether the application is up or not, what is the health check endpoint that I need to use? You see, this is not up because there is no application running on it, right? So likewise, for Kubernetes also, you need to define such things. So how do you define it? What do you define it? Is something we'll see in the upcoming session. Okay, so probes we'll cover later. Okay, probes we'll see later. We also have a concept called as HPA. HPA. So HPA stands for horizontal pod autoscaling. Okay, if you're talking about scaling, okay, you need to understand what is scaling, why you need scaling. Okay, so scaling is of two types. Okay, so scaling. What do you mean by scaling? For example, there are 100 users to Gmail. Then they'll be using one or two servers. If they have 1000 users, how many servers they would be using? 10 or 20. What if they have 10,000 users? They'll be using 20, 30. What if they have 1 million Gmail users? Then they'll be using 100 or 200 servers. This is called as scaling. Okay. So again, in scaling, there are two varieties of scaling: vertical scaling, horizontal scaling. Okay, so what is okay, in any cloud you take vertical scaling means adding resources to the same instances. Okay, so what is the example of it? What is the example of it? Okay, what is the example of it? Changing from T3.micro to T3.medium. So if you want to do it, downtime is involved, right? Agree? You need to shut down the machine and you need to do it. You take any cloud, in any cloud, scaling a resource vertically involves downtime. Okay. So, and again, for every resource that you create, it will have some limit. Okay. So for example, a maximum size of the server that you can create is, for example, 1024 GB RAM and 2 and 512 CPU. Okay. And again, the size of the resource increases, the cost of the resource also increases. Okay, so it's not like, okay, if I use one CPU, one memory on an instance, if it is costing you 100, if I go with the 10 CPU and 10 GB memory, it goes with the 10 times 100, 1000. No, it's not the cost. Better the size of the CPU and memory. If the size of the instance increases, the cost increases exponentially. So vertical scaling is always costly. Okay, so you can ask why servers with high CPU and memory are costly when compared in proportional to small servers. And always bigger servers with high CPU and high memory are becoming more expensive than the small servers because they utilize higher end components designed for heavy workloads, including powerful processors and all. Okay, so the size of the server increases. It's not just like, okay, I use one CPU, 1 GB memory, it is costing 100 rupees. If I use 10 CPU, 10 GB of memory, it's like into 10. So 100 into 10,000. No, it would be 5,000 or 10,000. The size of the server increases, the cost increases. Okay, so verticals always have some limit. And every hardware that you create will have some limits, right? You cannot have more than definitely they will be having a limit, but you cannot say, okay, my hardware cannot work beyond this, or my hardware cannot work beyond that. You can't do it, right? That's when we don't do vertical scaling. Okay, keeping the cost aspects in mind. For example, if this is your front end, if there is more load, I'll bring one more instance. I'll bring one more instance, and I'll bring one more instance. Okay, I'll bring one more instance, and I'll balance the load on the top here using the LB. And this type of scaling is called as vertical scaling. Keep in mind, vertical scaling is always costly. People always incline towards horizontal scaling. Okay, so vertical scaling always involves downtime because you need to bring that down. So this is called as a vertical scaling. Okay, this instance is grown to this. This is called as vertical scaling. Okay, this is called as vertical scaling. And this is called horizontal scaling. Horizontal scaling, there is no downtime. And that's the reason companies like Google, Meta, and Netflix exponentially they can grow big without the need of any sort of downtime to meet the capacity demands. Okay. In Kubernetes also, for the deployment, stateful sets, replica sets, there is a concept called as a horizontal pod auto scaling. You can define, I want to have a minimum of 3 replicas. Whenever the CPU utilization across the board reaches 70%, I want one more pod, one more pod, one more pod. You can define it. Okay, that's when HPA comes up into picture. HPA. You can scale it through CPU, memory. You can also create your own metrics. Okay. Second thing, daemon set we didn't speak. We'll see later. We can scale the pods of the deployment either by CPU or memory or by creating a custom metric. Okay. So this topic I'm not interested. This is as per the organization need. You can also create, like if the number of messages that are waiting in the queue is greater than 100, I want to increase the number of pods. You can also do that, but conventionally we'll go. Okay, so what I'm gonna do is this can destroy this one. You can also mention the scale up behavior and scale down behavior as well. HPA, Kubernetes. Yeah. Done. My app. Oh yeah. So this deployment, it starts with a minimum 2 replicas. and it can go to a maximum of 10. Whenever the target CPU utilization reaches 80%, it spawns one more CPU. So whenever you're dealing with any sort of HPA or any sort of deployment, minimum 3 replicas is recommended. And it operates by 80. Publish GP cap. Okay, it says namespace. So there is no such namespace. Okay, yeah. This is what I'm saying. It says in the auto scaling V2/B2, it's not available. So maybe they would have removed it in the beta 2. Now it's public. Okay, it still says it cannot be available. Maybe this feature is not available. Let's go. Okay, that's fine. So KC get kube control get API resources. I want to know which resource, which API it is available. Kube control cluster info, API resources. Yeah. So here I'm interested about horizontal pod autoscaler, right? Uh, uh, yeah, horizontal pod autoscaler HPA, and it is available in autoscaling/V2. Okay, autoscaling/V2. Yeah, it is in autoscaling only. And again, deployments. Deployment is available in deployments. Okay, which is available in app/A1, app/A1. Fine. Horizontal pod autoscaler. Autoscaling/V2. Okay, fine. Then why it didn't work? AC apply -F019. Horizontal pod autoscaler in version 2 cannot be handled as. I get it. So this option is not available in autoscaling/V2. Then what should I use? No, that's fine. So this is how you need to use. Okay. So horizontal pod autoscaler. So you need to use average target utilization. Metrics. Okay. Yeah, average utilization. Okay, this is how you can use metrics. Done. So with respect to API to API, changes will happen. So for this particular metric in the auto scaling V2 resource CPU, if the utilization is more than average utilization of the CPU is more than 50%, then it will create the pods. Okay, that's what it says. Can you see this HPA got created? Now go see get HPA. Can you see this? So you get this utilization in few moments because you already have the metric server in place. Kube control get pods. Okay, you can see my HPA is in place. Okay, so my app. Okay, now you can also see this whenever there is a utilization that is greater than 50%. Okay, metric server is going to collect the resources and it's going to mention it. If the resource utilization is greater than this, then it is going to scale out and scale in between these three. At any point of time, if you want to see what are the current replicas, you can see this. Okay, that's about HPA. You can play with either CPU or memory or even custom metrics. Okay. Next topic is as a part of the roadmap. Okay. Then what all we see? We saw the containers, okay, running applications, pods, replica sets, stateful sets, jobs. Okay, load balancing, networking, pod-to-pod communication is done, resource management is done, injection of config maps, secrets, monitoring the resources, quotas to namespace, limits and requests, scheduling is done, storage we saw briefly. Okay, auto scaling HPA we saw. Okay, cluster auto scaling will be covered with Kubernetes, EKS, VPA we'll see later. So security in Kubernetes, role-based access control, these things can only be covered in the actual proper cluster. Okay, creation of that, it's going to take 10 to 15 minutes of time. We'll see these aspects on the top of real cluster on Monday. So next 2 days, please ensure you practice better. Okay, and we'll start with the actual Kubernetes cluster. You don't see any difference, but what are the features that I need from Monday can only be available on the top of the EKS. Okay, that means we're gonna say goodbye to Minikube, and we'll start with what are we gonna start with? We'll start with EKS tomorrow, day after tomorrow. Okay, and that's for today, guys. Thank you. Any questions, anyone? Girisha, Harish, Rachit, Srilata, Sumit, Vikram, Ambit, Sridevi. Any questions, guys?
So I have one query, Manoj. So in few tasks, we have seen that in home directory, we are adding the disk. So is that kind of horizontal scaling?
Adding disk? Yeah, you can consider.
Yes,
Yes, you can consider because you cannot expand after a certain amount of time, right? Because you're doing resource utilization, disk utilization on the top of the same disk again and again. It is also called as horizontal scaling.
horizontal scaling. Okay.
But if you want to upsize the instance, when you're talking about scaling of instance, okay, vertical scaling of instance, vertical scaling of pod, I understood. But you are vertically scaling a disk, but there is no downtime, right? Is that what your question?
Yes, yes, yes,
I'm
exactly.
talking about instance. When I'm talking about the pod, the reference that I want to talk is instance. And that's the I clearly mentioned T3 medium to T3 micro.
Mhm.
That's a good question, but I already covered saying that I'm referring in the interest of instance. Okay,
Mm,
see this? And
correct.
that's a very good point, by the way. Okay, but we are talking in the context of size of the instance. Okay, it's a very good point. All right. So the next topic is security. We'll see the security later once we create the cluster. And that's it, guys. Any other questions, anyone? Anyone? Vikram, Sridevi, Srilata, Rachit, Harish, Girisha, Ambit. All right, then. That's for today. Have a great weekend. We're going to see tomorrow, day after tomorrow. Thank you. Signing off. Bye, guys.